I'm doing a LeetCode stream. It says it's an easy. We'll find out how easy it is. Oh gosh. Count odd numbers in an interval range. Okay. Given two non-negative integers, low and high. Return the count of odd numbers between low and high, inclusive. So for this one, low 3, 7. So they're all in that range, and they are all odd numbers. So you return 3 between 8 and 10, 9. Okay, it seems pretty clear what we're supposed to do here. So okay. Yeah, I thought we were going to be given an int array or something. And okay, so you're just supposed to find all the negative integers in this range is all you're supposed to do. So, all right. And the range can be from 0 to 10 to the ninth. Okay. Uh, well, that's interesting. Uh, I'm gonna just do a simulation deal and uh, do it that way. But I think there's a faster, more efficient way that you could do it by just like subtracting high from low and dividing by 2 pretty much would about do it as well. But there's some caveats there. So I'm just gonna do the like simple simulation way of doing it here, or try to anyway. Okay, I'm gonna make a variable count to be counting what we want to return. Then I'll make a for loop I equals low, I less than or equal to high. And then we'll do I plus, too many pluses, I plus plus, okay, if I modulo 2, because that'll determine its oddness, e equals 0, then I guess it doesn't equal 0. Then count plus plus, and I think that'll do it, but I don't think it's the most efficient way to do it. But we'll see if we can get this to work. Okay. Yeah, it worked. Let's see how it performs compared to everybody else's code that's done this problem. Well, there's a problem. TLE high equals here. Jeez. What? 10 to the ninth is how big? I mean, it's not a 10 to the 31 like the maximum int range or anything. Or no, that's 2 to the 31. Oh yeah. Oh gosh. That's a lot of zeros. Suppose that's 9 zeros probably, since it's 10 to the 9. Jeez. Okay. I'll check something real quick here. Multiples of number, maybe. Like, what is 2 to the 31? I'll ask AI. Okay. Well, let's go ahead and get this code. It worked basically. It just got TLE'd on like towards the end of the test cases. But I kind of expected that. Well, I mean, I expected it wouldn't be the best performing way to do it. It's like the very straightforward, the way the question's written, kind of thinking. Okay. So this is just a general question I need answered here. Like, how's 10 to the ninth compared to 2 to the 31st, which is like the int range sort of thing? I'll just ask which is bigger, 10 to the 9 or 2 to the 31. I mean, I would think 2 to the 31 would be bigger, way bigger, for one thing. Yeah. So yeah, now I can see with the commas that, yeah, that's a billion. So 10 to the 9 is a billion. Um, this is kind of your int range right here. Anything bigger than that, and you're going to need to use a long instead of an int in Java. I'm going to go ahead and take note here. Put that in my notes. Help me remember that. But at any rate, I mean, I'm guessing that's why it TLE'd. Let me see that. Let's see. Yeah. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, it's a billion. Okay. Low was 0. High was a billion. Alright. Alright, well, let's just try something. I think a tertiary type thing could work here. There's There's two different ones. So let's see. Let's just find out a little bit here. Test this theory out. Count equals low minus, well, I guess we should do high minus low. Generally, I guess in this case you'd want to subtract the bigger number from the smaller number and divide by 2. Let's see what happens. It's just there's going to be discrepancies, like if it starts on an even or an odd. So in this case, 7 minus 3 is 4 divided by 2, but both of them are odd, so you have to add 1. In this case, so what I get? Output is 6. High minus low divided by 2. Oh, low divided by 2. Okay. Let's put a parentheses on here and do this calculation before we divide by 2, for one thing. That would help a lot, I think. Okay, so yeah. So if both of them are odd, then you add 1 and it'll be right. Maybe, yeah. I think that's what's going to be the case. And if they're both even, then it just works. But what if one of them's odd and one of them's even? What happens? I'm wondering now. Can I make a test case? Yeah, I can. Okay. Let's make this 2. Try it. Okay. So it's the same. Okay, so if one of, well, if that test case thing worked there, I don't know for sure, actually. I mean, it appears to have worked, but I don't really know for sure. Okay, let's set that back to what it was. Okay. Oh, how you do it? You go like this. Okay. So if both of them are odd, you add 1. If one of them are odd, you add 1. Yeah. Huh. Okay. So let's make a tertiary thing here. If low modulo 2 equals 0 and high modulo 2 equals 0. In other words, they're both even. Then, let's see, how do you write that? Oh yeah, question, right? This is called a ternary operator. Do you do the if though? Huh. It's been a little bit since I've written or seen a ternary operator, I guess. Let me check my notes briefly. Maybe I have one in one of these other ones. I can glance at. I have so much code here. I'm sure that something has it due to this one had like 1,000 lines of code trying to solve it the other day. Okay, so is that? Yeah. Must have already shut that one. I don't see it here now. Okay, ternary operator. I don't see one. Okay. We'll find out. Or I'll ask AI. But we'll find out just by doing this. So if it's even, you want to return count. If they're both even, you want to return count. Otherwise, you want to return count plus 1. I think is what we're trying to do here. I'm not sure if this is written correctly. Looks like it was written correctly. Alright, so will this work? Kind of think it will. It totally worked. Okay. Yep, 100% code. We just calculated it. So yeah, if they're both even, then you return count, which equals high minus low divided by 2. Otherwise, if either of them or both of them are odd, then you have to add 1 to count due to, you know, having the odds starting and ending the range. That's the difference. Okay, so that's pretty straightforward. I don't know what else to say about that. So I'm going to call it a day here on this. So yeah, there's 2 solutions. One gets TL lead because it at 1,000,000,000, and the other one works 100% compared to the other solution, Java solutions. So let's dig into that just a little bit more about the. So memory, I'm a little high on memory, but 0 milliseconds on the speed. Is there anything I could do to reduce memory? Not really. I mean, I don't know. I don't know what you would do. So, yeah. Guess I can make this bigger so people can see it better. But it's pretty straightforward. You just calculate it. So, the number of odds in the range between low and high are going to be high minus low divided by 2. But if either high or low is odd, then you need to add 1 at the end. See, if they're both odd, then you still just add 1 because you're divided by 2. But otherwise, I think it's a case of it getting floored. In other words, brought down to the next lowest integer, because that's how Java works with ints and division and stuff. So I think that's why you have to add 1, otherwise, and just mathematically speaking, if they're both even, the low and high, then the range subtracted divided by 2 is the correct number of odds. But if low or high are odd, or both of them, then you have to add 1 at the to count, to divide by 2. Okay, yeah, guess that's it for tonight.